Hi everyone, we're going to look at the quotient rule now. This is the second part of today's lesson. So the quotient rule is another formula which you're given, and in this case, let me snap this one again. Get this one up. Let me snap this one again. And so here's the quotient rule, this thing here. So what do we mean when we say a quotient? Well, first of all, we're talking about a division of two functions. So I don't know, maybe for example, one of our functions is x squared plus 1, and the other function is, what did I use last time? Sine of x. Okay, that could be a quotient of our two functions. It's basically a ratio of two written as a fraction. So when we say a quotient, we mean a division of two things. Okay, so there's a new rule for this, and it looks really complicated. Obviously, you get given this, but again, I write it in this form. I say VU dash minus UV dash, which is really similar to the previous one. Apart from you need to have this the right way around because there's a minus in the middle. So the way I tend to remember this one, not particularly useful perhaps, but the way I tend to remember it is that V starts on the top and it's on the bottom. You know that V is on the bottom, then it starts the thing on the top as well. So we've got VU dash minus UV dash. So divided by V squared in this case. In fact, a lot of these functions here, you could actually say that is actually the product of two functions. You could say it's the product of x squared plus 1 and sine of x to the minus 1. And it's true, so we could then use the product rule with this and this, but then we end up using the chain rule inside of the product rule and it becomes more complicated. And we just get to the same form anyway, because you always end up doing the same process with this chain rule essentially here. So so that's why we've got this separate way of writing it out. It's just much easier and neater to use this. Again, I'm giving no proof of this one, but you're given this formula as well. Okay, so we're going to have a look at example 14. So let's snip this one. Example 14, and I might not do all of B. We'll probably talk quickly through B. Let's just have a look at the dynamic here. Okay, so we'll look at the technique of this first of all. So we've got u is equal, same thing but as before, u is equal to x squared plus 3 and v is equal to x plus 1. And so u dash is equal to 2x and v dash is equal to 1. Okay, now we need to use our rule. So remember what our rule is. It's vu dash minus uv dash divided by v squared. So that's what we're going to use. So if we substitute things in there, we've got x plus 1 times by 2x and minus, what's v dash? V dash is 1. So we're just left with u there, which is x squared plus 3. Remember, of course, your brackets, because when we have a minus on the outside, it's going to make it a minus 3 there. We remove the brackets. Right, divided by v squared, so we've divided by x plus 1 squared. There you go, there's your dy dx, and actually that one's super quick because there's no extra chain rule or anything to do there. And that's much easier than treating this as the product of two functions, x squared plus 3 and x plus 1 to the minus 1. Okay, for the next bits, these bits you've done before. So the equations of the tangent and the equations of the normal at this point here, it's just the same, right? So we can substitute minus 2 into this function here and find the gradient. And so once we've found the gradient, we say y equals mx plus c. We've got the coordinate point and the gradient, then we can substitute in here to work out what our plus c is. And that's for the tangent. And if you want the equation of the normal, it's the same thing again, but whatever we get out as the gradient from here, if we get out as the gradient from there, we're obviously going to do, so you get 2, then you're going to say, well, the gradient is now minus a half. Then it's the same thing again. You substitute that into here, and you combine that with your point, and you work out what C is. So the second part of that question is not difficult. Guys, thank you for listening today, and good luck with these tasks.